Excellent. Well, I hope everybody's doing good today. I spent a long time getting this presentation done. I wanted to make sure and not give too much programming heavy stuff up front, and kind of give the more open source intelligence gathering, that kind of juicy bits up first, so that in case you are like me with a short attention span, you get all the kind of more important stuff first. Then we're going to move into kind of the more details of how to troubleshoot a little bit of stuff, and look at some more kind of core Python functionality. So a little bit introduction about myself. Give me a second. A little introduction about myself. I'm Jeff, of course. I'm a web app pen tester, and I play a major role in forensic investigations here at Alias. I have 2 certifications. One is GSEC, which is the GIAC General or Network Security Essentials, and the other one is the GCFE, which is a Forensic Examiner certification. Those were pretty difficult to get, but I've used them quite often in my job role. I have 14 years of cumulative experience in information technology. I basically got started at Dell when I was about 21 years old in break fix, and I learned a lot about user behavior, and got my start in programming doing some PHP MySQL there. So I've been in the industry for a minute, and professionally I just started working for Alias about a year ago. So it's going to be, yeah, we're coming up on a year. So it's a great team of people. They're very skilled, very talented. And so I'm also about to be a dad to a baby boy named Callum. It's going to be an interesting experience being a new father, but hopefully we get along and I can teach him a little bit of hacking. All right, so a little bit about us. Alias, we do cybersecurity assessments, penetration testing, social engineering, security awareness training, incident response, and digital forensics. You guys heard from Don earlier about kind of the red teaming or finding hackers. And so we were founded in 2010, and we have over 30 years of experience in performing all these services. Let's see here. All right. Sorry, I'm a little bit nervous, man. So why Python? So you hear a lot of talks, or a lot of people talking about different security tools or different scripting tools, excuse me, for any kind of programming and for security work. So Python is the most common, but you also hear people using Bash scripting straight from Bash. You hear about people using JavaScript to collect data and to do intelligence. But in general, I found that Python is the most easy to use for me personally, just because of a few things. One of those would be automatic memory management. So if anybody has ever tried to code in C, that requires you to declare how much memory you're going to use that memory, and then free it up. Python does all that for you. So it makes the coding a little bit less complex whenever you don't have to manage your own memory. Another good feature about Python is that it's dynamically typed. So instead of having to say, I have a string or an integer, this is what it's labeled, you can just pick a name and then add a string or integer value to it without having to declare it first. So it makes it a lot easier to understand code at times whenever you don't have to initialize each variable before you use it. And the most important thing, like I touched on, is your human readable syntax. So Python has a bunch of conditionals. Some of my favorites are the words not, or is. So what that means is, in Python, I can say if a integer is not 100, kick me into an error message. So basically, the not is, it's human readable words that let you perform logic operations in Python. Okay, so interactive mode. Python allows you, so since it's scripting, Python allows you to open up this interpreter, and it starts you in interactive mode. And what that does is it lets you test out different code. So essentially, you can import a library, you can send a command, and you can live look at the responses and look at variables and what data they hold without having to save that script and then compile it or run it through Python. So it's actually a interactive live console. It's much like Node.js, if you've ever used that for a console. So in this image right here, we start by importing requests. In this example, we basically make a simple GET request to our website, alias infosec, and then we want to figure out the status code. So we are able to do that, like I said, live inside of here, as well as search for strings inside of the HTML response. So we're looking for the word cybersecurity in the response from the GET request to alias infosec. And of course, it is in there. We can also look at the response headers. So what content type was set by the user. So we have all of these parameters that we can A, access, and B, do it live without having to, worry about code management as much. All right. So the title of my speech is Async Intelligence Gathering with Python. And so the reason why I wanted to include that caveat is because of the crazy speed advantages that asynchronous programming provides a person. So in a typical synchronous client-server interaction, you'll have the client make a request, the server receives and starts processing the request, but the client waits for the server to respond before it proceeds with giving another request or a follow-up request. You'll see this kind of stuff in NMAP, where NMAP will basically scan for a host, depending on how you've had it configured, but a standard configuration or scan will scan one host at a time sequentially. So asynchronous, what that does is it basically allows us to execute many requests without waiting for the server response before doing so or before moving forward. So on this graphic right here, I don't know how good it is to, or how easy it is to see, but on this graphic right here, you can see kind of the flow or control flow that you would have. Let's see here, I'm gonna get a laser pointer for you guys. So you see the kind of control flow, whereas you can make the request and the client can continue working even though the server hasn't responded. So a good example of asynchronous versus synchronous in a practical use case is if you're doing a scan and one of the ports is hanging, then the program can't move on to scan the other ports. It's waiting for the response from that port. But if you have asynchronous scanning, then the server, even though it can't wait for that or doesn't have a response from that port, it continues with its port scan. So what that allows us to do is make so many requests all at once, essentially, and then wait for everybody to send us a response back, but continue processing. And does anybody have any questions that I could clear up? I may be being too technical or talking too fast. Is everybody good or have any questions up to this point?
Real quick, if you could just verify that your Discord is muted.
Yes, sorry about that, guys. Give me a second here. Give me 1 second here, and I'll mute that. All right, there we go. All right, so yes, so asynchronous versus synchronous has major speed advantages. So let's look at two tools that are commonly used in our line of work, and let's kind of do a comparison on them. So NMAP is a great tool for doing port scanning. So is Masscan, but like I said, NMAP does it synchronously. So Masscan is very fast. It uses the asynchronous scanning technology, and it basically can return a wide number of hits for ports way quicker than NMAP. The difference between them, the other differences between them, however, are that NMAP is a lot more full-featured. So you can run different scripts within NMAP. You can set different timing. They both share similar syntax, but in general, Masscan's a port is open or a port is not. It does have support for some banner grabbing, but in general, it's just good for open ports unless you harness the power or leverage the power of its results, which we'll do in a minute. So both of these testing suites or scanning suites have the ability to output in JSON, which is JavaScript object notation, or to output in greppable format. So format that you can easily grep text out of, and that's going to be standardized essentially. So let's take a look at a NMAP scan, and we will time we'll time how long it takes. So I basically looked for a random CIDR range in Oklahoma City, and I am scanning just web available ports, and so we're timing that. So as you can see, we scanned 256 addresses. It took about 2 minutes. So if I run the same scan with Masscan on the same CIDR range, I can scan those same 256 hosts in only 26 seconds. So the difference in those two is that Masscan is 128% faster, and this is just with a single CIDR range. So the difference is in asynchronous and synchronous are exponential. So even though it was just 128% faster on that particular CIDR range, the wider or the wider your range is, and the more hosts you scan, the more speed you can have, or the more speed advantages you can utilize within Masscan. So here's some packages that with Python are very useful, especially in the web scraping or intelligence gathering realm. Basically, requests makes some HTTP requests. It's a full library where you can do get, head, post, options requests. Beautiful Soup parses the HTML that's generated from a request. And then Selenium's a little bit more of an interesting beast. So Selenium, it requires a separate binary, but what it does is it actually emulates user behavior in the browser. So we'll take a look at some details of these kind of packages here, but these are some of the tools and packages that I use the most within the Python environment. So request package, like I said, we can use this to make GET requests, post requests. We can even set custom headers, set custom cookies, define post parameters, as well as it has support for sessions. So we can carry on cookies and data across different requests. And this will become very useful with one of our case studies here. So in this example up here, the first line, I import requests, define a response, and post this data to this URL. So you see here, request bin, another tool that I'll touch on a little bit. Request bin is able to pick up this request, and this is a good way to debug data if you're trying to send it out. It's a good way to see how your structure is, if you're using the right headers, if you're using the right encoding, etc. So again, this is request bin. It's a great place to post data if you have some endpoint testing that you need to do. I wouldn't use it for any sensitive or classified information. It's very easy to derive the actual dashboard URL from the posting URL up here. But it is a great tool. There's a few others out there. Bceptor is one, but they're basically bin type places where you can send post requests and see what data you're actually sending out. So here's an example of some code for Selenium. And so I'll touch a little bit on the difference between Selenium and Beautiful Soup 4. They both use browsing, or they both use HTML parsing. But the difference with Selenium is I can actually do things like click on links. So I can look for every link in a website, then I can click on those, and once I'm in there, look for content. So it's a lot of JavaScript interaction as well that you can do with the browser through Selenium. So in this code sample right here, and I've included line numbers in this code, in these codes, so if anybody has any questions about a specific line, then you're able to reference it easily. But essentially what we do is we start a new browser object with a Chrome WebDriver, and we load up yahoo.com. So what you don't see in this code is I've made a query to yahoo.com, and we basically, for each letter in that query, I type it out onto the screen, and then I sleep randomly between 1/10 and 8/10 of a second. And so what this does is it basically makes the keyboard look like a user is typing it. So there are different APIs that you can utilize to access Google searches, but I don't trust them as much as I do scraping the actual Google site, acting like or emulating like I was a user. So if you do a lot of automated requests, say you used requests library instead of Selenium, if you use a lot of automated requests, you usually get flagged in Google, then it will have you do a CAPTCHA. Well, I don't want to be hit by a CAPTCHA when I'm supposed to do, or when I'm trying to do research, but I also don't want API filtered results. So this basically, and I'll show a demo of this, this basically allows us to emulate a user's mouse and keyboard within a browser. And so it creates a lot more value when you're testing sites. It does, like I said, though, require you to download a separate binary versus these other libraries or packages that I'm showing. Selenium does have support for all major browsers, and it controls it by direct communication. So moving on to Beautiful Soup 4. Like I said, this is for pulling content from HTML and XML. The advantage of Beautiful Soup would be, unlike Selenium, we don't have to load the entire website in memory. So essentially, Selenium, it loads a browser, and then it has to load all the content or all the resources and assets, so pictures and media from that browser within it to be able to start running. Well, Beautiful Soup 4 can just parse HTML directly. So that's kind of one of the advantages if you want to be quick. So right here, this is a scraper that I made for the Oklahoma County Secretary of State. It just so happened that they were using incrementally increasing IDs for every company. So I thought, why not take advantage of that and build a list of company names and email addresses for myself and for possible leads. So we have right here, we define our URL. And within the URL, or after we define our URL, we make a GET request. After that GET request is made, if there is a 200 response, which means okay, what we do is we load Beautiful Soup and process that HTML. So once this Beautiful Soup right here has been instantiated, this HTML object is what holds all of that data. So what you see on this line 37 is we have a table, and we're basically telling it to find in that HTML a div element that has an ID of print div. So in my research of the site, there was the same area that had the same data that I needed. So because it was static, I could basically target this specific element and then pull the company name from that element. So what you see here again, HTML I'm gathering, I'm finding the table by ID, then I'm saying the company name is whatever's in that table under an H3 tag, I need that text, and that's the company name. So that's kind of the power that you have inside Beautiful Soup 4. And of course, I looped that and incremented that number by 1 each time, and I got a decent amount of results. And no resetting connection or blocking the connection. So it was very fruitful, and that's kind of the way that we take HTML content out of web pages. And do we have any questions up to this point? Okay. So one of the common issues that you run into when you're gathering information or data is you often have data that's buried among other sets of data that you don't want. So being able to identify what data you want or not in a sea of data is very hard. So regular expressions are what we use to find this data. A regular expression is a sequence of characters that defines a pattern. So as you can see right here, we've got a string, which is our address. And then we say our zip code is this pattern, if you can find it from our string. So this pattern right here, basically what it says is, I need anything that's 0 through 9, and only that, and it has to be five character count. So what you can see right here from the regular expression was that we pulled the zip code from a full address. Digging even deeper into kind of more our realm, here's if we have an HTML comment. So some people put on their websites, some developers, I have been a developer before and still am, some developers include comments on their source code, which you never should. Why would you? But they do. So in the event that we were parsing thousands of web pages, I would maybe want to look for things like hashes, or maybe encoded passwords or hash passwords, sorry. So I can down here define, again, a pattern. It has to be 0 through 9, uppercase letters A through F, and a minimum of 16 digits. And you see down here, we can pull that hex code from HTML where it's buried. A great tool to use for testing out regular expressions is Pythex. And Pythex will let you type in your regular expression up at top. You can set different options down here, multi-line, all being verbose. But basically, you put in a test string, and it will show you live what data is being matched. So this expression right here, I'm trying to find phone numbers that have the parentheses. So this is very helpful. Like I said, pasting in a whole entire page of HTML. If you just want to find something in a single element in the HTML, this testing a regular expression before you have to use it in code or use it in an interpreter is it pays off, and it's very useful. So let's talk about a case study about how can we get data. So we've got or intelligence. So we've got we have resources as engineers like DNS Dumpster, Qualys, Shodan. There's tons of resources out there, but I hate paying for a lot of them. Or I hate having to swim through a bunch of data just to find the actual piece that I need. So what we're going to do is we're going to take a look at how we can get just the IP addresses out of DNS Dumpster, and from that we'll look at how to use those tools to facilitate that process. And I have a few more tools to show you after that. So you can see DNS Dumpster, it returns a list of hosts, which is our domain name, of course, IP addresses, and your who owns that block. Well, if you've used this before, you know that it limits it, which is okay. But we're going to create a query or a Python script, excuse me, that's going to use beautiful soup requests, etc., to pull out this data. So the first step, if we have a intelligence asset, we'll call it, and we want to pull data from it, the first thing that we want to do is open up the HTML. So what I did was I right-clicked on one of the IP addresses and hit Inspect Element. What that does is allows you to open up this inspector mode and look at HTML. It also lets you search within this HTML, so it can be very useful. But if you right-click and inspect an element, it's going to take you directly to where that element is in the browser. So in my research, I noticed two things. One is that we have a cross-site request forgery token. And then we also have this input named SYNSCAN. And that looks like the IP addresses that we're wanting. So up here, we have a row, and we have row data, or row cells. And basically, we have multiple rows that have these IP addresses. So knowing that SYNSCAN in my previous research is attached to nothing else but the inputs that have these IP addresses, how can we get that out? So now we've identified a website that we have data that we want. We've inspected the source, and we've identified kind of a unique way to identify the data we want, but we still don't have a way to actually extract it. So here is a script that does just that. And so this code, after my talk, I'm going to be putting a lot of this code on my GitHub so that everybody can see, and we can, my GitHub is on the intro slide, but I can put it in the Discord as well. So up at the top, we start by creating a session. And then from that session, once it's established, we request the dnsdumpster.com URL. We use Beautiful Soup to then find that CSRF middleware token. So basically what I've done is this first URL is like first hitting the browser. So when you first hit the browser is when that middleware token is generated. So we want to make a plain request to the root HTML page to get that token. Then we want to take that token and carry it through the session. But what we also want to do is supply a IP address. So, excuse me, starting from top, we start a session, we use Beautiful Soup to find the middleware token. Then we take that middleware token and attach it to the target IP. The next thing we do is create a second post request and we post that data. Once that data is returned, we then identify all table rows. We loop through the table rows looking for the SYN-scan input. So in Beautiful Soup right here, you see the syntax, it's fairly easy or fairly clear. So if we want to find an element that's an input with the name of middleware token, that's the syntax. So it's like I said, Python is very easy to read. This dictionary this way is very easy to pass parameters. Anyways, we've looked through all the SYN scans that we identified previously after we've made that request. If we do have a input that has SYN scan in it, we append that to a list. So what we do now is after we have that list, we give a little bit of output. We choose a file name, which is the argument you pass, so the domain name, and then we add this text extension. We write every IP in that list to a file. So I've gone ahead and done that. Excuse me, I hope I don't lose my voice, man. I've gone ahead and done that. So what you can see is if I run the scrape program on our IP address, it shows we collected 4 IP addresses. And then if I type that out, using Windows for this one, if I hit type and type that out, what we have is a list of IP addresses. So what we can do now is we can use that for other tools. Now, obviously, this isn't a major list of IP addresses, but if you think about scripting out or looping through scraping IPs from domains, then you can collect a wide number of IP addresses. So I took it a little step further and thought, how if I can, so say I can scrape DNS dumpster, right? And I get a list of IPs, then what? I still have to look them up. So another powerful feature with any programming language is sockets. So it's writing raw data to a port. And so what I've done here is I've taken up here, you see I'm finding the SYN scan. And if it found a scan, I try to get the host name by its address, which is get host by ADDR. And I pass it in the value of SYN scan. If there's an exception, I set it to false. But I basically append this to my list. And so again, since the list is written to CSV, or not CSV, excuse me, it's written to a flat text file, I can type that out. And what you see here is we've actually identified host names now and IPs from just a single domain name. So I'm sure there's other tools that can do this, and I know there are, but the whole idea behind using Python for this is the ability to chain these things together so easy. So you know, in one of my other slides, I'll show how we chain Python to other programs. But essentially, I can take a list of IPs, run a socket on them, or I can pass it on to something like Dirbuster, or pass it on to something like Nikto, or I can even filter out things like NS or mail from the host name, so I don't get any assets that I'm not really interested in. Do we have any questions up to this point? Okay, so here's a demonstration of, speaking of automating tools and using Python. We know that Masscan is fast, right? But if Masscan is fast and it's async and we write Python that's synchronous, it's going to be limited and there's going to be that bottleneck. So what I did was I realized that in a lot of our research, it takes a lot of intelligence, a lot of upfront intelligence work. So if I have a wide amount of IP addresses, or excuse me, hosts that I want to check, I want to just see what's the HTML content, or I want to see maybe what the title tag is, and that's all I want to see. I want to see it quick so I can know if I need to investigate further. So the problem I was running into was the scans of synchronous scans were slow. So I went async, but even after going async, it still takes manual entry or it takes some further investigation. So this tool, I'll show you some of the code behind it, but basically what it does, it takes a pre-made IP list or a CIDR range as you've seen up here. And it basically loops through, it runs Masscan, and it converts Masscan to grepable output. Once that output is produced, Python picks it up, and then it starts making asynchronous HTTP requests to all the websites, and then pulling the first 256 characters from the HTML body. And so I'm going to demo this really quick. I hope that the video works on over compression, but let's go. So here you can see I've got Masscan firing off. It's very quick. So I don't know why it has this little delay. It's built in, but I'm sure we can turn it off somehow. So essentially, everything that matched port 80 within that range, what you see is I'm getting the little bits of HTML that are the first 256 characters. And so at the bottom, you see 64 hits from 256 hosts in 20 seconds. So we were able to scan a 256 host CIDR range and in 20 seconds get a preview of all the HTML. Now, when I showed one of our other engineers, Andrew Lemon, this, he said, "Bro, Eyewitness is that." And so it was, I looked at Eyewitness, and Eyewitness does have some functionality, but Eyewitness, it would require some modification, and it is very comparable. But like I said, we can chain into other things. And so while it is good, I like to make it myself if I can. So this CIDR range, by the way, was Google's CIDR range. So these are all pretty much similar because they're just load balanced Google's. So here's another demonstration. This is kind of one of the tools that I like the most. Like I said, it emulates user behavior in the browser. So it was created to find websites containing a specific term. And the long-term goal would be historical. So if I can find the top 10 sites on Google for a certain term, and I can do that continually and alert me, say if after 10 days there's an anomaly, then that may provide some, excuse me, that may provide a little bit of information that I can have for further investigation. So there's multiple things that you can do by just searching through sites and doing it automated. So essentially what I do is I start Chrome driver. We find that search field in Google. I go inside of it, and then I start typing like a user would. But really what you see is you see cybersecurity being typed out, and you'll see the random delays. And it's pretty slick, I think. But you'll see the random delays. And so what it does then is after it searches, it hits next. So I predefine a number of pages, like I only want you to search 5 pages or 10 or whatever, or unlimited. But I say after 5 pages, look through each URL. Then what it does is it takes those URLs and it passes it to requests. After it passes the URLs to requests, it does a regular expression looking for the text or term that we've supplied it. So after all of that, after all that's done, it basically gives us an output of every URL that had that text inside of it, and then also gives us a little preview of that text. The reason it gives you a preview is because Beautiful Soup is finding the text within elements of HTML. So say there was a paragraph block that said, "My name is Jeff, and I got attacked by ransomware." It would find that whole text instead of just the word ransomware. So just kind of that side effect of searching through Beautiful Soup 4 gives us a preview. So anyways, I've talked enough about it. Let me go and show you what it looks like. So there it is. I want to play Cyberpunk 2077. I don't know if anybody else is interested in that, but anyways, we searched cybersecurity. We typed it out slow, and now the browser, as you see, Chrome is being controlled by automated test software. So we hit next a bunch, and then what you see here on the screen is, so from every URL that we searched on, for every URL that we searched, we're now parsing it for that word. And so the reason that this is slow compared to the previous is because this is actually done synchronously. So I do Selenium in the browser, but then all the requests are processed synchronously. And so that's why async is so powerful, because this would probably have already been done if we were able to not have blocking or be waiting on other responses. So you see the URLs up here we found, and we see the text, and like I said, the preview of that text. So there's more interesting uses of this, of course. There's obviously nefarious uses of this, but essentially being able to find that list of URLs that match a search term without triggering Google that you're a bot, and without risking getting filtered results through an API, it's beneficial, and it feels good tricking the browser. So, like I said, we have tools that exist in Kali, in Linux, whatever distro you use. We have tools that exist, but harnessing those tools or the power of them or kind of leveraging that can be difficult. Python makes it pretty easy. I'm sure most programming languages make it easy, but my example is Python. So if you see here in our first result, the first tool demonstration that you saw, where we scan all those ports and then find the HTML, just the HTML preview. So we basically take a CIDR range and we run a sub-process through Python. What you can see right here is we're referencing the Masscan binary. We're saying -p for a port, and we put the port that the user provided. OJ means output in JSON format. The dash means to standard out, and then we got a CIDR range. So basically, this is running a Masscan scan, and it pipes the standard out and standard error to this variable. Next thing we do is we look for the results, and we parse that whole JSON string and loop through it. When we loop through it, we're basically appending HTTP to it with the URL, with the port that the user specified. So that's essentially a way that we can take Masscan, which is asynchronous, and then code that's asynchronous and chain them together so that we don't have a bottleneck. And so that's why that first tool that I demonstrated is so quick, because it literally does not wait before it sends another request. Do we have any questions or feedback up to this point? Sure. So one of the big things in scraping or intelligence, in my opinion, is avoiding detection. First is having quality data to scrape or gather, but avoiding detection. So in a lot of circumstances, activity that's repetitive is going to be blocked by a firewall IPS system. Fail to ban is one of the Linux services that does this. There's plenty of others, but a lot of times the source IP or originating IP or the user agent is used to identify a user. And so if there's enough hits on that same user agent with the same IP, it's probably the same guy versus being, say, an office where a bunch of people are at. But regardless, any way that they can use any way that a person can use to determine if an automated or scripting is running, we want to try to defeat, because we don't want anybody in our business, essentially. So what we do here, and also if we had 1,000 URLs to scrape, it'd be different. You know, scraping one URL or two, you can get by with that. But scraping many URLs on the same block could be difficult, because you may get blocked. So what you see here is we define a list of user agents. So this is a standard Python list, and you see some user agents, as you are familiar with, or should be familiar with if you're in the industry. And then we define a proxy list. So we define a local address port 8080. And so why I did that is because I actually routed this demo through Burp Suite for you to see. So while true is basically an infinite loop, we basically select a random user agent, select a random proxy, create a request. The next time we create a request, we select another random user agent, and we keep going and going. So what we could have done is taken a whole list of URLs and a whole list of proxies and basically made the request on those through the proxies, and that would essentially look random, or it should look random, to a lot of firewalls, IDS, IPS. So heuristical analysis may cause an issue, but this, if it's something static like source IP and user agent, then we may be able to get away. So let me go ahead and show you what I'm talking about. So I ran this. Here we go. So you'll see in this demo, I have Burp Suite loaded. And if you haven't used or are familiar with Burp Suite and you're in web or even in IT, it's something interesting to see how traffic is shaped and how traffic moves through your network, especially HTTP, excuse me, traffic especially. So we've started a burp suite proxy on port 8080, and in our, just like our example page, what we have is, or not example, but our example previously, what we'll do is we'll make random requests, but we'll try to switch up the proxy or the user agent. I'm not switching the proxy because I only have one. So let's go ahead and run that code. So I'm spitting out which proxy I selected, the user agent selected, and the URL that I'm trying to access. So I killed the code. That's why you saw the error. And what you see here is you'll see me stepping through Burp Suite. And if you'll notice the user agent, so let me get my pointer here. Anyways, pointer's being laggy because of the video, but you can basically see the, here it is, user agent down here changing. So that's kind of the intelligence gathering, that kind of section of it, portion of it. Like I said, I wanted to give those juicy bits up first, but these are the kind of nuts and bolts of the work. So let's go ahead and talk about storing data and kind of debugging a little bit in virtual environments. I won't get too much in the weeds for you guys. I hope I haven't already, but if I have, I apologize in advance. So storage modules. Everybody's heard of CSV. Most people have heard of SQL. So CSV, anybody can open that in Excel. You can edit and save CSVs in a notepad or any kind of other text editor. SQLite. So SQLite has some basic SQL functionality and syntax, but it has very limited data types. So what that means is you may have text or integer, but you won't have some more advanced data types like MySQL has. So MySQL, the difference between that and say SQLite is that it has users and permissions. So I would say that CSV to SQLite to MySQL is a progression and a good progression depending on how large your environment is and how much data you need to collect. So SQLite module, you see most of this, or almost all of my code examples, I show the import statement. So you can really see this is almost a complete SQLite block of code. So I import SQLite, define the file that I'm going to be loading. And in this example, this was the results from the companies I scraped from the Secretary of State. So I basically want to find the last filing number so I can continue my search from there. So what I do is I provide my SQL query, get a cursor to the connection, and then execute my query on the cursor. After that, I can loop through rows and basically view all the data that is in my SQLite database. So SQLite, according to their website, is 35% faster than reading or writing to individual files in the file system. So if you did have CSV and you're using it and your application was writing many times at once, then it probably would be applicable to use SQLite instead of creating new files or to be accessing the file system. And the application file is portable across all systems. So what that means is you can send a SQLite file to your friend, they can open it up with a SQLite browser, whereas you can't do that with MySQL, but you can with CSV. So it really depends on what your use case is as why you pick one or the other. So here's a good CSV example. I start by importing the CSV module and request and beautiful soup. Why not use them all? So I define a list of URLs, predefined list. Some sites I frequent often, I guess, GitHub and Hacker News, but we've got our website in there as well. So I basically make a blank results list and I loop through the URLs, requesting each one at a time. So then if the status code is 200, I find the title and I append it to my results, what you see up here, list. Another thing I want to touch on real quick is template tags in Python. So this F right here that you see before a string, that allows me to place any variable directly inside of a string without having to concatenate. It's very, very, I've fallen in love with them so far in Python. So digging further into the code a little bit, we basically open up a CSV file with write permissions. And we define that we want to use non-numeric quotes, which is essentially just quotes. Then we write the row, title, and URL. So this gets our first row written, but then we loop through our results and write the subsequent rows. What you see here is the output. So we said we want the title, or the headers should be title, URL. And so we have then the title of our site, and we have our URL. The title of GitHub, UTF-8 was probably something going on right there, but that's okay. And then we've got Hacker News, of course, the title and the URL. CSV is very decent in storing data quick. So when all these Python packages that I'm talking about, they can get kind of tricky to manage. So Kali has a bunch of different tools and scripts that rely on different Python library versions. So creating a virtual container for the different libraries is essential if you don't want to break your system or mess up, or if you want to kind of isolate code. So up at the top, it's a simple curl. If you already have Python installed, that's good. If you don't, python.org will get you there. So we make a simple curl request to this Python file, we output it. Never directly run bash on a file you download, but if you do, it's your skin. So then we run Python get pip, and that will install the pip package manager. So if we were, say we had a brand new Python install and we want to do what we talked about earlier, we want to experiment with requests. How do we get requests on our instance? Well, we type pip install request after we've installed pip, and it's done. So it's really fairly easy. NPM is another package manager. Apt is similar to this syntax. So installing pip, installing Python, they're fairly easy compared to others like Visual Studio and having to statically link libraries to your executable. So some useful commands would be pip freeze, which basically freezes your whole entire library that you've installed in your virtual environment. And what this will allow you to do is create a requirements.txt file, which you'll see in a lot of GitHub Python examples, for if someone wants to download your repo and get it running, they can just install all the libraries that you've put in that file without having to do research or dig through error codes. So it's very helpful. So now that you have, now that we've gone over package managing, virtual environments are major. Like I said, they isolate your packages from conflicts, etc., and you can even install different versions in different environments. So the flexibility is there. So to instantiate a virtual environment, we type Python 3. We specify the module as the venv module, which you can install that through pip as well. And then we say this is the folder that we want. After that, we define the source of our environment to be inside of the virtual environment folder, inside the binaries called activate. As soon as we run that command, you see this over here, venv will drop down into our virtual environment. And so once we're in our virtual environment, that's where we want to start installing our libraries and keep them just contained inside of our environment. So here is what you'll see is a pip list, or is the results of pip list. And you see packages that I have installed as well as requests inside of there. So that's pretty blank list. And so, but our request is in there. So it lets you see in your virtual environment how many packages are installed and what are they. To get out of your virtual environment, you type deactivate. And what that does is just drops you out of the virtual environment. And to test that we've actually successfully dropped out, we can do a one-liner to Python trying to import that module, and you'll see no module. So we know that this virtual environment is contained. So debugging. Debugging is major. I use it so often. And so we'll go a little bit into that. I won't get too much in the weeds because it gets deep, but something very useful. If you use Python and you're not familiar with PDB, you got to get familiar, man, because it's the way to identify problems and look live. So we start by importing PDB, which is the Python debugger. It's interactive, just like the interpreter. So when we drop down into a PDB shell, we can access variables, we can manipulate variables, we can do a lot of stuff within debugging. So what I've done here is made a URL list. A-list infosec, I turn myself into a pickle Morty. I bet you that's not going to show up and give a 404. Probably isn't. Well, I know it isn't. Then we have aliasinfostack.com, which we know will come up. So let's simply loop through the URLs, making requests. But if we get a 404, let's drop down into a PDB shell so that we can see what's going on and inspect the code, inspect the objects in real time. Otherwise, print a success message, and just like we did in the other tool, show me the first 256 characters of that response. We can also change the program flow, and I'll show you a little bit of that here. So let's run the debug test. So we get a 404, and like we thought, we get dropped down into a PDB shell. So you can see the, man, I left my username in there, dang. I thought I cleared everything out. But you can see right here that we're running debug test, and on line 8 is where it's breaking into that PDB shell. So now that I've gotten a 404 on this URL, what's up with it? So as you see, I'm in the PDB shell, and I do r.headers. So this r.header shows me the response headers that I made of the request. And so it's very helpful that you can see if there's any headers up here if you're debugging a URL, you can see the headers, you can see the status code, and then you can also influence the flow of your program. So what I mean by influence the flow, so we started with the 404 first because we wanted to be dropped down in the debug shell. So after that, after we've determined, okay, that URL is bad, I hit URL, looked at the headers, looked at the status code, yeah, something's wrong with that. But what if you want to keep going through your code, but you don't want to have to get out of your shell? You can hit C and hit enter, and it continues execution. So the shell was paused. Once we hit C, it continued, looped back through, and found, hey, that site does exist, and now you see the first 256 bytes of Alias's website. So I covered a lot of stuff. I hope I didn't get too much in the weeds, but like I said, Python is great for open source intelligence. We do a lot of it up here, and I'd love to answer any questions if you guys had them. And again, I'll be available in Discord, and aside from that, I'll post GitHub.
Thank you very much, Jeff. And we'll pop over to Discord and see if anyone has any questions.
Okay, thank you guys so much.